An event happens in cell A such that it can be dissipation, reuptake back to cell A through the terminal buttons, metabolize, but the one that we are concerned with is when it binds to the postsynaptic receptor, synaptic vesicles emptying into the synapses, binding to a postsynaptic receptor binding site on the dendrite of cell B, presynapsis and postsynapsis.
Outside the cell is the interstitial fluid, and inside the cell is the cytoplasm. The post membrane is in between the lipid bilayer. Receptors span the lipid bilayer. However, most of the time, the pore is closed. When the neurotransmitter binds to the binding site, the pore opens, which is permeable to sodium. Sodium goes into the cell, and it pushes its way into the cell by using two pressures, osmosis and electrostatic pressure.
Because the cell has a phospholipid bilayer, that means that it is semi-permeable, which means ions can pass through the membrane of the cell. In this situation, sodium begins the process of osmosis, where it moves from a higher concentration gradient to a lower concentration gradient inside of the cell. As sodium moves into the cell, a process called electrostatic pressure begins to occur, which means that ions of similar charges repel each other and ions of opposite charges attract one another. As sodium moves inside of the cell, its positive charge begins to repel potassium's positive charge, which begins the process of depolarization.
If the neurotransmitters were to bind to the receptor's binding site, and then the receptor opens and the sodium enters the cell, you would see a slight rise on the oscilloscope called the EPSP. The EPSP stands for excitatory postsynaptic potentials. EPSP registers depolarization of the cell due to the entry of sodium. EPSP is when ionic trophic receptors, dendrites of cell B, are open due to the presence of neurotransmitters.
When you have large amounts of neurotransmitters present, causing multiple EPSPs and adding more positivity to the cell, it is called summation. This process of temporal or spatial summation continues until the threshold of negative 65 millivolts is reached.
Then there's a massive influx of sodium in the cell, so much that it reaches plus 55 from minus 65, and massive depolarization. At that point, sodium is at equilibrium, but the thing is, potassium gates open. And since the cell now is so very positive, and potassium is greater inside the cell, the concentration of potassium is now very positive, and the positive charges repel each other. So potassium exits the cell. And as it happens, there's a very large and steep hyperpolarization of the cell. So we have the upswing and the downswing of the action potential. Potassium is attempting to reach its equilibrium point, which is minus 75 millivolts. And what it does briefly is the cell brings the cells itself brings the protein on the cell membrane. And the sodium-potassium pump brings the cell back to rest. The potential obeys the law called the all or none response. There is not half of the action potential. It has to continue all the way to completion, and it happen in discrete places, such that it starts at the axon hillock, and when it reaches the edge of the myelin sheath, and when it reaches the myelin sheath, it spreads like a wave and travels to nodes of Ravier to nodes of Ravier. And so at each particular node, you will have a potassium gated channel and a sodium gated channel, allowing sodium to come in and potassium to go out. An extra potential to generate at that node. This process of action potential moving from node of Ravier to node of Ravier is known as saltatory conduction. Saltatory conduction is the process by which an action potential seems to travel down the axon shaft. So here you have time 1, and time 1 has an action potential. At time 1, the first node of Ravier is at rest, and as well as the second and the third terminal. At time 2, the axon hillock has returned to rest, but now the action potential has been moved to node 1. At time 3, the action potential is at node 2, and it keeps going. Finally, the action potential gets reaching the button, and that's towards the end of the story. When the action potential reaching the terminal button, it interacts the calcium in a way that the vesicles bind to the inside of the presynaptic membrane, and they slowly open in a process called exocytosis. The molecules of neurotransmitters are spilled out into the synapse between cell B and cell C.